Greetings and welcome to another video in the Aviation Safety Risk Management series. This one is dealing with simulation and specifically discrete event simulation. And the idea behind this video is to just build a foundation. This will be sort of a building block approach as we take a look at some of the basics in this video, and then in subsequent videos we'll look at some more advanced applications and eventually work our way to a very powerful risk management tool, Monte Carlo simulation. So let's jump into this. And there are only a couple of things to cover in this video. The first is just sort of a philosophical disclaimer, but then we'll just jump into the idea of building a simulation. And there's really two parts of simulation. The first is the simulation itself, which is interesting, but not particularly useful. What's really useful is being able to extract data from the simulation. There's a purpose for building the simulation, and getting information that's useful to us is really the goal. So again, just starting with sort of a recognition that this simulation that we're going to talk about, this type of simulation, requires independent random numbers. And the second bullet there sort of poses the question, can a machine do that? And the short answer is no, not by itself it can't. What's happening when we see random numbers come from a machine is we're running some kind of an algorithm that's producing something that looks like a random number, but it's not truly random. And we call them pseudo-random numbers. So there are some tests. If you were to create an algorithm, you can test it to see how well it performs compared to other algorithms that do this. Here's a lattice test is what this is called, and you can see right away that the little algorithm there at the bottom, which does produce something that looks an awful lot like a random number, at least at first glance, definitely has a pattern to it. Here's another type of lattice test, a three-dimensional one, and once again you can see a very clear pattern emerge in the data. So these numbers are not truly random, but for our purposes, just in learning simulation, they are more than adequate, mainly because we, looking at the random number being produced, have no idea what's coming next. The last bullet there, I just invite you to kind of copy that and paste it into a Google search. And if you're interested in the types of algorithms that are used today, that's a good one to check out. Very interesting how that was developed and how it performs today. All right, so in a previous video, I introduced this very simple game, the coin toss game, and I'm going to use that again to provide a demonstration of what simulation is all about. So just as a quick review, the game is very simple. You toss a coin. If it comes up heads, you win. Otherwise, you just keep playing. And this is the same little risk framework that I put together to demonstrate some of the terms we use in probability, and it also just sort of graphically describes this game. So the first thing we want to do is we want to be able to simulate the coin toss itself. And that's sort of a valuable skill right off the bat. But again, it's not as useful as we might think. What becomes useful is when we're able to pull some information out of that simulation. And to kind of give you a little bit better understanding of what I mean by that, as we look at this risk framework and all the math that's going on inside it, and you think back to the idea of an expected value, something I introduced in the previous video, there was a kind of a scary looking mathematical equation that went with that term. And the question that I would throw out is, can you look at something like this and determine what the expected number of coin flips is, the expected value? I don't mind telling you, it doesn't jump off the page at me. I'm sure if I sit down, I can put the equation together and I can eventually figure out exactly what the answer to that question would be. And if we have the ability to do that, it might be the best answer, because that analytic solution is not going to have any margin of error associated with it. It'll be basically a perfect answer. Now with simulation, the difference is we won't get a perfect answer. Instead, we'll get sort of a ballpark estimate of what it is with some margin of error based on the sample size in our simulation. The good news is we control that sample size. We can simulate it as many times as we want to, and the more we do it, the better our information will become. One other thing, just as a sort of a second piece of information we might want to extract is, over some number of games, what's the most we should expect, the most number of flips in any one game? And there's probably a dozen other things we could ask that are similar, but this will give us two questions we can attack in a simulation. So what I want to do now is I want to get out of the presentation mode and get into a spreadsheet. And what I've done here is I've sort of pre-populated this spreadsheet with a few fields. And I want to begin right here by just producing a random number, step one. And we can do that in Excel just by typing equals RAND. You can see the tool tip pops up. It might be a little bit too small to read, but if I just use an open and close parentheses here, this is going to generate a random number between 0 and 1. Now there are some other options in Excel, but we're just going to keep it simple for this video. And voila, there's our first random number. And now, what's the result? Meaning, what does this mean, heads or tails? That's kind of what I want the result to be. Now, notice that up here, I've put some data in, the probability of heads being 50%. And I find this to be a very useful technique because now I can link all of the fields in my simulation to this one cell. Suppose I have a coin that doesn't have a perfect 50% chance of heads and tail. What if it's not a fair coin? And I want to run this same simulation for a coin that has a 55% chance of heads or a 45% chance or some other number. If I link to this one data point, I can change it in one place and my entire simulation will update all at once. So it's just a very convenient way of doing it. Let's see how that works. Again, combining sort of the art and the science here, there are probably dozens of different ways that we could construct this, but I'm just going to stick to the very basics and I'm just going to use if-then statements and very simple if-then statements. So I'll start by doing this. I'll say if the number to my left here, this random number that I just generated, is less than this probability that I have up here, and I'm going to anchor it by putting a couple of $signs in there. That tells Excel I always want you to look at cell B2 regardless of where I copy and paste to this equation. And I'll just say that that's going to be heads. Otherwise, I want it to be tails. And there you have it. So we have just completed the development of our first simulation. And what I can do with this now is I can copy it and I can paste it anywhere I want, as many times as I want. And you can see now I have a simulation involving 5 tosses of the coin. But again, that by itself is not terribly useful. So what I'm going to do now is I'm going to add a couple of additional fields so that I can start to extract some information from this simulation that'll help me answer the questions that I posed. So the first thing I'm going to do is I'm just going to sort of put the rules of the game into this simulation. And again, they're very simple, but I'll say that the game outcome is something that I'm interested in. And I'll say if this result right here equals heads, then according to the rules of the game, we'll say that's a win. Otherwise, I'm just going to leave it blank, and we'll just kind of understand that to mean we just roll again. And then again, I can copy this thing down, and you can see every time that heads comes up as the result, the game is won. Still not really giving me a lot of good information yet, so I'm going to put a couple of additional fields in here. The first one is I'm going to create a number here, a flip number. Basically, every time I flip the coin, I'll just number it. First flip, second flip, third flip, and so on. And then what I really want to know is, what was the winning flip? So what I know for sure is the very first time that I throw the coin, I can just kind of hard code that in there. I know that's number 1. But from here, I don't know. It's going to depend on what happens in the simulation. So what I'll do is I'll start off with another if-then statement, and I'll just say if the previous game ended with a win, so I'll say if that equals win, then what I want to do is I want to start renumbering at 1. Otherwise, I want to add 1 to whatever I had before. And I can fill that down a little bit, and you can start to see that working. And now the winning flip is relatively straightforward. If I just say equals if this over here, this game outcome equals win, then I just want to know which flip it occurred on. Otherwise, I'll just leave it blank again. And I can copy that down as well. And now you can start to see I've got the beginnings of a simulation where I can actually pull some information out. Let me do this. Let me grab this and let me scroll down to 1,000 rows. And so now as I scroll back up, you can see, sure enough, I've got 1,000 coin flips, and I can make many as I want to, 5,000, 10,000, but this should be enough. And the expected value is essentially the average of the winning flips. So what I'm going to do is I'm going to use Excel's average command. Again, there's a tooltip that pops up for me, and I'm just going to tell it the range. So it starts in E6, and it goes down to E1005. And there's the average number of flips in the games that are played there in those 1,000 rolls. Similarly, I can just say equals the max. Same range again, E6 to E1005. And it turns out I had at least one game where there were 9 flips before the game was finally won. Now, as I hit the F9 key on my keyboard, there's several others you could hit too to just refresh all the random numbers. And each time I do this, you can see I come up with a new result. So 1.91 this time, or 1.92. Again, 1.92, 1.85. There's a 2.04. And you can start to see that as I do this over and over and over again, the numbers are tending to hover right around 2. And so just at a glance, my guess is that the expected value is 2 flips. And if you think about a 50% chance of a coin flip, sure enough, that makes a lot of sense. And I'm sure we could derive that analytically, as I said before, and prove that the expected value is exactly 2. But this simulation that we put together just in a matter of a couple of minutes allowed us to get this ballpark understanding, and that might be enough, and it might be a very quick and easy way to get to it. What happens if I change the probability of heads? How would that change the expected value? Well, it certainly would. Let's try a 30% chance of heads. Now, intuitively, if you win when you throw the coin and it comes up heads, and you reduce the probability of heads, my expectation is that the average number of throws that it takes to win would go up. I have to throw the coin more often. And sure enough, right away, as I reduce that probability of heads, you can see the average went up. The question is, how much? I had a pretty good understanding of what was going to happen to the numbers, but there's no way I could have guessed how much. And even now, I don't know for sure that 3.5 is the right number. You can see that it's bouncing around from 3 to 3.6. So again, just by refreshing this over and over again, I'm going to say that the expected value is somewhere between 3 and 3.5, maybe 3.25, something like that. And this is, again, this is a fairly good illustration of what simulation can give you, but also what it can't give you. It's never going to give me the perfect answer. And if I need to know exactly what the expected value is, I need to calculate it. But if I just want to know, get a rough idea, then doing it this way, putting this kind of a simulation together, can help us get in the ballpark right away with very little effort. All right, that's all I have for you for this particular video. If you need to get in touch with me for any reason, my contact information is right there, and you know the drill with any YouTube video. Likes and subscriptions and all that kind of stuff are always appreciated. Hope to see you on the next one.